Okay, so this is 6.2 slope. Slope is muy importante. Probably didn't say that well, did I, Pamela? No. Was it okay? Was it so-so? Is it livable? All right. The slope is very important. Very important. And it's something that comes up in algebra a lot. And it's a concept that is a foundational concept to a lot of other math. And honestly, when a student finishes Algebra 1, they expect them to understand slopes very, very well in all the aspects of them. So it's a real important topic. All right, we've kind of introduced slope a little bit already. And again, what is it? It's the vertical change, which is the rise. So the ratio, meaning it's a fraction with the vertical change on the top and the horizontal change, the run on the bottom. Rise over run. I think I gave the illustration a week or two ago about the plumber plumbing the toilet. Was that you guys?
Yes.
And he better have a good rise over run. And it better be sloped the right way, otherwise there's going to be trouble. All right. Yeah, plumbers use rise over run all the time. Whenever you put a drain line in, you need a certain, really rise over run is the term. It's really a negative slope because that thing's going to drop. And you want it to go so much amount and drop, and so much amount and drop, and so much amount and drop. Rise over run. Carpenters use rise over run. They'll use it doing a roof. They'll use it doing steps. Matter of fact, the part that you could kick on a step, the vertical part, is called the riser. That's the riser, right? And the horizontal part, the tread, but that has a slope. Steps are supposed to have a set slope, a rise over run. On a roof, each roof has a set rise over run. The whole section of the roof has the same slope. Okay? Now you can have gables and stuff like that, but that's another section of roof. Any section has the same rise over run. Sometimes they call that pitch as well. A plumber can use the word pitch as well. All right, so what is the rise? It's the vertical change. The symbol is a triangle for change. And your vertical, is that the X's or the Y's? Say it. Vertical. X's or Y's? Y's, right? The Y is the vertical axis. So the rise is the change in Y. Triangle Y. You don't say triangle Y, you say change in. You could also say delta Y. That would be the physics term. But delta means change in. So the change in Y divided by change in X. That's the slope. The vertical change over the horizontal change. Now, because the change in Y is the vertical change, the up and down, we know that positive on the Y-axis is up, right? And we know that negative on the Y-axis would be down. The bottom is the change in X. So if you have a bottom number that's positive, then it's right. If you have a bottom number where the bottom is literally negative, normally wouldn't leave a negative in the bottom. But if in this case it is, then negative would be left, right? So vertical, positive up, negative down. Horizontal, positive right, right? Negative left. Okay, backwards. Not easy to figure out there, right? So take a look at our line that's graphed here, and I have 2 points that are obvious, right? So we can figure out the slope of these 2 points. So I'm going to start here at this point 2. You don't need to circle it. And I'm going to go vertical to try to get to the same level as the other point. Would you agree I have to go up that far? So how far did I go up? I went up 5. The Y value changes 5. And is that positive or negative? It's positive because I went up. Now to get from there over to the other point, I have to go to the right, 1, 2, 3, and right is positive, and I have a positive 5/3. So for this example, our slope is 5/3. I go 5 up and 3 to the right. 5/3. Let me ask you something. Does -5 over -3 equal +5 over +3? Does -5 over -3 equal +5 over +3? Negative divided by a negative is a, so don't they equal? Okay. Don't do this on your graph because you'll get it too busy for when you look at it later on to try to understand. But watch, let me start at this point. Okay. Let me go down 5. -5, right? Now if I go left 3, don't I head back and hit along the line again? Sure. Because a -5/3, a -5 over a -3 is equal to a +5 over a +3. Would we ever leave a slope with a -2 over a -7 or a -5 over a -3? No, we would always write the positive part because we're writing a final answer. But they are equivalent, are they not? They're equal. They are. And by the way, again, don't write this on your notes because it gets confusing, but any 2 points along the line have that slope. For example, let me do the y-intercept. Again, don't do this in your notes because it'll get sloppy. I'm going to go up 5. 1, 2, 3, 4, 5. That's up 5. Agreed? If I go to the right 3, I should hit the line. 1, 2, 3, and I hit that point right there and hit the line. It's that ratio everywhere along the line. Now, the whole line has the same slope, does it not? Of course it does. So no matter what 2 points you pick on the line, the ratio will be 5/3. Okay? Now, how about 10/6? Would that be true? Yeah, because 10/6 is 5/3, isn't it? Okay? And there's all kinds of different ways you could say the ratio in equivalent fractions, right? Makes sense? So the slope of the line. All right, so let's look at a couple aspects here. So we have such things as, use your green here, positive slopes. I want you to try to get the concept of what a positive slope is. I'm going to need you to look here. Don't write this on your drawing, just on your notes, just watch. Let's look at this point right here. You would agree the input, the x, is a -3, right? The output, the y, is what value? Say it if you know it. 0. Can you not figure out the y value is 0? Right there? 0. Okay? We okay? You follow what I'm doing? Okay. Now, as I move from left to right, let's see what happens to the y value. Now I'm going to choose this point. The x value is 0, and really it's this point here. The x value is 0, and on this one, and I just put a circle over it, the y value is 4, right here, right? The y value is 4. What happened to the y value as the x value increased? Did the y value increase or decrease? It went from a 0 to a 4. Did it increase or decrease? It increased. Positive slopes, as the x increases, the y increases. That's a positive slope. You want a quick visual? Does the line, all off now. Come back, wherever you are. Does the line go up as you move from left to right? And the answer is it does. And if it does, then it's a positive slope. And again, if you look at the numbers, what's the vertical change 4? What's the horizontal change? 3. It's a positive 4 divided by a positive 3. Isn't that a positive slope? It absolutely is. And again, don't forget, I think you guys have one more m in your notes, right? You can also write this as a negative 4 over a negative 3. That's still a positive slope. And I think your visual also gives the negative part, does it not? You guys have like a negative 3 going like this. And the, whoops, should have been green. And the negative 4 like that, right? Okay. Now, if you look to the right, then this is obviously going to be a negative slope. We can have negative slopes. Notice how you go left to right. By the way, Madison, there's 2 seats right up here if you want to take one of them. I know you're struggling with your glasses there. You're more than welcome anytime you need to use one. It's up to you. Don't want to embarrass you. Hopefully I didn't. Sorry about that. But notice the line here on the second one. As you go left to right, start left, head to the right, what's happening to the output? The outputs are getting lower. Remember, the y is the output value. X is the input, y is the output. Input -1, output somewhere around 4. Input is 0, now we're down to 3. Input a 1, now we're down to 2. Input a 2, now we're down to 0. See, as we increase the input, what happens to the output? It decreases. That's a negative slope. And again, notice the numbers. The vertical change is -3, and the horizontal change is +2. We got a negative over a positive. And again, in your notes, I showed you the other possibility. Hey, all right, so what if you want to go up 3? You can, but then you got to go left 2. And aren't those equivalent? A -3 divided by a +2 is a negative slope, and a +3 divided by a -2 is also a negative slope, right? Both cases, you get a negative slope. So we have positive slopes, they go up to the right. We have negative slopes, they go down to the right. Always, always. Doesn't matter where the line is. Don't do this in your notes, it'll be ugly. Okay? Negative slope, down to the right, right? Negative slope, down to the right. Negative slope, down to the right. Negative slope, down to the right. Negative slope, down to the right, right? I mean, doesn't matter where the line is, as long as the line is heading that way. Positive slope. Positive slope, positive slope, right? All kinds of different positive slopes as long as it goes up to the right. Up to the right, positive slope. Down to the right, negative slope. Again, please ask questions as we go if there is a need for questions. All right, number 1. Let me get higher here for you. So the formula defines the slope of a line through 2 points. This is important that you associate this formula with that idea, the slope of a line through 2 points. Because very soon we're going to have the formula called slope-intercept form of a linear. Okay. Because the top is the vertical change, it's the change in y, correct? Here's how we're going to say it. Y sub 2. Y with a 2 subscript. It's the way you say it is Y sub. It's short for subscript. Y subscript 2. Y sub 2. And it simply means the y coordinate of your second point. Subtract from it y sub 1, the y coordinate of your first point. That will give you the vertical change. Then on the bottom, it'd have to be x sub 2 minus x sub 1, right, which is the change in x. So the formula is going to give us the change in y over the change in x. You'll say, Mr. Scarfy, they don't tell us which point is point 1 and which point is point 2. It doesn't matter. Call one of the points point 1, call the other one point 2. I do advise this. I can't tell you how much, I mean, this is so important that you label your points. The x of point 1, the y of point 1. You know what I see some students think? This is x sub 1 and this is x sub 2. Well, no, every point has an x and a y. This is X of 0.1, Y of 0.1. Label it. You won't get confused. Label the other one, X sub 2, X, Y sub 2, because that's the X and Y coordinates of the second point. It's going to help you get everything in the right place when you run your formula. So let's go ahead and do a couple examples. I'm going to be smart. I'm going to label. Going to do both my X's at one time, both my Y's to save my color there. Now tonight, when you guys do problems like this, fat chance of that, I will want you to use the slope, finding the slope of 2 points formula. I want you to write it each time. Why do I want you to write it each time? So you'll remember it. Because again, you got to remember this formula. I don't give it to you on a test or quiz. You got to remember it. So again, every time you write it, better. We're not going to rewrite it right now because it's right there, but in your homework, you would rewrite it, okay? Each problem, rewrite it, because you got to memorize it, and that's going to help you memorize it. All right, so M equals. I'm going to do my Y's in green. So I put a 12 in for Y sub 2, right? I got my minus in between. I put my 9 in for Y sub 1. Divided by X sub 2. See how it helps having things labeled, right? By the way, you should be looking at the formula. You don't even have to look at the board. Look at the formula. The bottom left is X sub 2, right? That's 6. Then comes a negative sign with the formula. You're looking at your formula. Then comes X sub 1. And read your X sub 1 with your chart. Right? We're just subbing into the formula. Now we just got to simplify. So the top is a 3 and the bottom is a 5. And we get 3/5. This line has a slope of 3/5. For every 3 units up, it goes 5 units to the right. Could go 3 miles up and 5 miles right. Could go 3 inches up and 5 inches right. It could go 3 kilometers up and 5 kilometers right. It's in the ratio of 3 to 5. 3 units up, 5 units to the right. Make up your own unit of measure. Okay? Make up the kid. It can go 3 kids up and 5 kids to the right. Sure, the kids have their own unit. They need it, right? So many kids. All right. So 3 up and 5 to the right. All right, so see if you can do B. Go ahead and try B. Again, you can write the formula again if you want, or you can just go right off of it. It's right there for you. Go ahead and solve. I'm going to pause the video. All right, hopefully you got it. Woohoo. Look at that. See, I saved myself. By labeling. It's so easy to get them mixed up. How many got negative 3/8? Okay, you can put your hands down. What's the obvious pitfall on a problem like this? What do you have to be careful about, Ethan? Mixing the numbers up, number one, and that's why we label them, and that's why I caught myself, because I don't know if you saw me doing it, but where the 4 is on the top, I put a negative 3 at first. But then when I went to use the negative 3 again, I thought, wait a minute, I used the negative 3 already. I must have gotten it mixed up. I caught myself. What's the other pitfall, Andrew? Yeah, be careful with the negative there. The first negative is part of the formula. Second negative is part of the coordinate, right? So therefore, you get 5 plus 3 is an 8. So how many got that right again? Okay. So be careful using the slope formula to find the slope of 2 points. Be careful, be careful, be careful, be careful. Got it? Whoa, where's my next page? Okay, number 2. 2 special slopes. 2 very special slopes. And these are ones I hope you guys will get down now, and hopefully you'll have them the rest of your math career. The first one is a horizontal line. A horizontal line. What is the slope of a horizontal line? What is the slope? What is the value of the slope of a horizontal line? There it is.
0.
Okay, I hear 0. I hear 1. It is one of those 2 answers. Is it 0 or is it 1? How many of my 0 people are there? How many 1 people? All right, so we have a bunch of 1-ites. We have a bunch of 0-ites. It looks about 50-50. Connor, you must have some sway. Or maybe people were looking to see if other people raised their hand or not and whether they were going to go. All right, let's find out. We can let the math tell us. So, you agree the blue line is a horizontal line, yes? All right, and I chose point 1 and point 2, yes? Let's run the formula. So again, go to the right here. So the y of point 2 is 2, and the y of point 1 is 2. Right, so we're going from there to there. And on the bottom, the x of point 2 is 3, and the x of point 1 is -4. Do you concur? Look, you're reading right off. You guys are squinting reading the board. Didn't I get y2 from there and y1 from there? Don't you have that on your paper? Don't you have x2 there and x1 on your paper? Think about what you're doing, not just copying. If you're just copying, you're not learning a thing. You got to think about what you're doing. If you're just copying, then you got to go back and figure it all out. Okay, so what's our top? What does the top become? And what is the bottom? 7, right? And we all know that 0 divided by 7 is 1, right? Anybody want to convert before I write the final answer? All right, we should have lots of conversions because the slope of a horizontal line is 0. Would you agree this has no slope? Do you want to ski this? No, then you're cross-country skiing. That's no fun. Do you want to go sledding down this? No. All right, you want to sled down that. All right, that'd be awesome. There's no slope, right? The slope is 0. All right, I forgot this lesson is this long, so the good thing is we're going to stop here and no homework tonight.